Hi, everybody in Research Methods, Psych 290. Today we cover correlation. Once again, this is an important topic, just like t-tests, not just for you to do well on the exam, but also because many of you are going to do a correlation for either one or perhaps even both of your hypotheses. Again, the whole idea of a correlation, we've covered this before in this course, but it is one group of people. You assume everyone is part of the same group, but they have two number scores. So in the case of your study, if you're doing correlations or a correlation, your survey score, what is the total score on the survey, and then maybe the person's age, or how many hours they work per week, or their GPA, or some other demographic question. Now, if you wanted to correlate all of those different kinds of number scores, that would be a multiple regression. But we're not doing that for this paper, multiple correlations. We're going to do individual correlations. So the person's survey score and their age. That would be a common example. So there's a little background. Let's get started here. First of all, look at the definition of correlation. The existence of a systematic, consistent relationship between two variables or events that can be measured numerically. Well, what else needs to be said? Just kidding. That's very confusing. We need to translate that into English and have it make sense, don't you think? So let's go through it step by step. First of all, a correlation can range from negative 1.0. That means that every time one of the numbers goes up, the other one is going down at the same rate or same interval. A correlation could be positive 1.0. That would mean that every time the first number goes up, the same number goes up by the same amount or interval. Those are rare. And you know what else is rare? A correlation of a perfect zero, where two factors are just not related to each other at all. That would be rare also. Most correlations are somewhere in between. There is a range here between negative 1.0 and then you get to 0. Sorry, my artwork is horrible, I know. I'm the first one to admit it. To positive 1.0, that the factors always move in the same direction. Make sense? All right. That's called the correlation coefficient. And by the way, it is the Pearson R. In case you're looking for it, the Pearson R. Does that even look like an R? There we go. That's a little better. Carl Pearson, the mathematician, is the one who invented it. By the way, his cousin on his mother's side was Charles Darwin. So I think they had some brains in that family, huh? Two famous people in history. So the Pearson R is the correlation coefficient. Now, you could have a positive correlation. The factors go in the same direction. Did you know that research has proven that this is true? Education and income, it's not a perfect positive 1.00 because there are people who did not go to a lot of schooling and they make a lot of money. Think about Bill Gates or Mark Zuckerberg from Facebook. Did you know they both did 1 year of college? I know what you're thinking. Well, damn, I'm done. I want to be a billionaire after 1 year of college. Most people don't do that. Most people, the more schooling, the more money. The less schooling, the less money. So that is why it would be a positive correlation. When one factor is up, the other factor is up. When one factor is down, the other factor is down. That would be a positive correlation. One up, the other up. One down, the other one is down. A negative correlation is not a bad thing. We get that in our heads sometime, that positive is good and negative is bad. This can be a strong correlation, a strong relationship, but the factors work in opposite directions. So look at the example here. The more you're absent, the lower you score on the test. The less you're absent, the more you score on the test. Those factors work against each other. They correlate negatively, which again is not a bad thing, It's just the number scores work against each other. It would be a high negative correlation. Are there any people who never come to class and they still get an A? I agree. I hate those people too. But really, they're rare. For most people, attendance leads to lack of absences, I should say, in this case, leads to better test scores. So moving right along. On a scatter plot, you've seen these before, probably, in math classes and other places, but you plot each person's score. So, are you a baseball or softball fan? Well, if not, you can pretend. Higher numbers on one variable, higher numbers on the other variable. How much are you practicing in the batting cages? And what was your batting average for the season or the month or whatever? Do you see how these vary? It's not an exact straight diagonal line. So that's why it's not a perfect 1.0. There's probably players who barely practice and they do really well, and others who practice all the time and they don't do so well. But for the most part, what kind of trend are we seeing? A positive facing diagonal line, meaning a positive correlation. More practice, more success. Less practice, less success. What would be a negative correlation? Well, for better or worse, another sports example. So we have female gymnasts, their height, and their overall scores. Do you see a pattern here? It's not going to be a perfect negative 1.0, but there sure is a trend, also known as regression line, and it is a negative facing diagonal line. So what does that mean? That the taller you are, the lower your scores, there's a pattern, and the shorter you are, the higher your scores. That would be the pattern for female gymnasts. By the way, I have a daughter who took gymnastics, and I remember at the end of each session, the teachers would come talk to the parents. I've never felt so tall in all my life because I'm an average sized man, but when these women would walk up to us and they were all 4'11", fully grown, I'm like, wow, now I get it. There is some truth to that. Negative correlation. Now, here's where it gets a little complicated. Two other correlation scatter plots that I want you to know. This one is called no correlation. These factors are probably close to zero, maybe negative 0.03 or positive 0.05. It would be a very, very low correlation. So, where's the regression line here? The answer is there isn't one. Now, when I become rich and famous, and you hear of Dr. Silberman's theory of correlation, it's going to be for this. I gave this a name. Tell me if you agree. I call this pattern, you ready? The chocolate chip cookie pattern. Do you see why I call it that? Because there's no correlation, and you just draw a circle around the whole thing, and to me it looks like a chocolate chip cookie. I'm joking about being famous. That's just the way I see it, as a chocolate chip cookie. No correlation, or very little correlation. Then, the last one I want to show you is called non-linear. Linear means a line, but non-linear means it's not a straight line. So, this is true in real life when this has been studied. You are at an out-of-town college and you live in a dorm and they measure your homesickness. Where is it at the beginning? I would say it's pretty low. Would you agree? Homesickness? What happens after you stay there for Halloween and Thanksgiving and maybe you come home for a week for Christmas or two? Homesickness goes up. Maybe you don't even want to go back for the second semester, but you force yourself to do it anyway. Where is the pattern heading? Back down again. That is a line, but it's not a straight line. So this is a non-linear correlation. There are other things in life like that too. Like how much you are uncomfortable working somewhere at the very beginning. Maybe You're not, and because it's so great to have a job, and then it goes up again, and then it goes back down again. There's a lot of things in life like that. So a non-linear pattern. It's still a correlation, just not a straight line pattern. So there are 3 examples here, which you don't need to do. I can give you numbers on the Canvas page for this if you want to practice doing these. In class, we would spend the better part of a day practicing numbers, and I would secretly give you each a number, and you would have one number for one variable and the other number for the other. I will post those to Canvas in case you want to practice to see what it looks like. The first one here is, what is your score on the Beck Depression Inventory? But the first score is the X variable. How many sessions of therapy did you go to? If you go to more counseling, does your depression go up or down? You can probably guess what shape the correlation would be. Second one, self-efficacy. Do you believe in yourself? And what about your algebra final exam? What direction do you think that would go in? The more you believe in yourself, the better you do, or the worse you do? And then the third one, what direction would this go in? The relationship between marital satisfaction and the years that you are buried. If you want to see the answers to this, look on the Canvas page. I will post numbers for you, and you're welcome to practice and see if you come up with the same numbers, but also you will see the answers that I tabulated for you. Now, speaking of that Canvas page, you will also see this. You will see that I posted a little addendum, I guess I would call it, an extra thing here to have correlation make even more sense, so you'll do well on the exam and well on your paper. First of all, it is very important to keep in mind that just because things are correlated does not mean that one caused the other. Here's an example. Did you know that soda consumption has gone up in the last 75 years? Approximately 100 years ago, in the early 20s, there were, I think, 11 kinds of soda in the United States. Now there's more kinds of Mountain Dew than that. Can you believe that? There's all kinds of Mountain Dew, but still, soda consumption has gone up. So has cancer. Oh my goodness, did the soda cause the cancer? Not necessarily. We don't know that for sure. Correlations are not cause and effect. All they show is that 2 number scores are related to each other. Second thing you want to know here, don't think that a negative correlation is necessarily a bad thing. Here's an example here of a negative correlation. The more stress you have, the less exercise you get, might be a strong negative correlation, whereas motivation and exercise are moderately related, not completely. So that's just good to know. And last thing here, this is something that you want to know for the exam as well as for your paper. I don't want to get ahead of myself. The coefficient of determination, R squared. What does that mean? You square the correlation, and that tells you what percent of one factor explains or predicts the other in a percentage. Why did I write through that? I should have written under it. You know what I mean there, right? Percentage explains or predicts. So, like what? Well, here is an example taking the SAT in high school. See if I can do that better now. Percentage explains or predicts. So, you take the SAT in high school, does that explain or predict how well you will do in college, your GPA? And the answer is, the correlation is not that big. 0.40 is the R, the correlation. Well, if you square 4 or 40, 4 times 4, you will get 16%. In other words, if I know your college GPA your first year, I can predict about 16% of how well you did on the SAT. And if I know how well you did on the SAT, I can explain or predict about 16% of how you did with your GPA. They explain or predict each other, R squared, coefficient of determination. Now, let's get ahead a little bit here. You have an assignment / quiz like you do most weeks. These questions here are going to look awfully similar to what you will find on that assignment. It's going to be different this time because you're going to have to wait for me to grade it rather than seeing a grade right away, but I promise I'll do that quickly. Well, it will be these questions, and you're supposed to think in terms of correlations are not really cause and effect. It might seem that way, but there's no proof. And then you also have to think in terms of positive versus negative. It's not like positive is always good and negative is always bad. It may seem that way, but that's not true. A negative correlation can be quite meaningful as well. We are done with this chapter. That is it for this one. We've covered a lot of ground here about correlation. And again, this is important for your exam, but also for your paper. And there's going to be a lab about this as well. That's it for now. Take care.